Welcome everybody to our Seafloor Habitat 2.0 Ignition Con. This is a very important matter for me, this conference. I was thinking about it for a long time. And when I asked everybody, hey, would you like to join? I was very much surprised that I got that much positive response for it. So thank you for everybody who's joining at the moment, everybody who's going to join now. First of all, my name is Martin Henke. I'm the founder of Calamar Park, which is an initiative for developing a new generation of undersea habitats. We do this since several years, and I got a lot of support from many different people. Yeah, this is the conference is about this. How can we start to make a new generation of undersea habitats? And it's just thought as an information platform as well. Very shortly about the goal of this conference, which is to define and take first steps to establish usable living space on the seafloor, to bring together people from different sectors with a potential interest of using underwater habitats, and to offer an information platform for potential funding parties, which is of course the most important thing. I don't like to talk about money, but it has to have a financial background, of course. And my main idea for this conference was to finish this kind of echo chamber. We are always talking and talking. We want to make it like this and like that. And it doesn't help if I talk and somebody else talks. The idea is that we come all together one time and we say, yes, we want to do something like this. And we go out to the public, and hopefully this mission is, this message is spread a little bit, and maybe finally we find some new ignition to get into a new generation of undersea habitats. That's why I call it the Seafloor Habitat 2.0. I wanted to emphasize that the first generation of seafloor habitats was mostly in tubes, and it was experimental. And every time I was wondering why it was not going on, why it stopped, why there were no new developments there. And so what we did with Calamar Park was to investigate all habitats that were made so far. We tried to find out what were their advantages, their disadvantages, and especially the question, what exactly stopped them from new versions. So we came to hundreds of different conclusions, of course, but there were some conclusions that I think they are significant for this research, which was mobility or lack of mobility, modularity, habitability, serial production, and financial sustainability. We took all our conclusions and we tried to fit them all into one design. And maybe I can try to show you some of the graphics we made. We came in the end to a design which looks a little bit like this, but don't misunderstand me, this is not the final design, this is an orientation. What we want to emphasize with this is that in this habitat, all kind of technical demands are included. You will see it like this. We have some habitable space inside. To get away from this tube design to some rectangular rooms, we have here some kind of a corridor, which is a social space, let's say. We have laboratories here. They can be used as guest rooms. They can be used whatever is necessary for the certain mission. And these two covers at the sides, they are actually empty. There's nothing inside. They are just like caps. They can be taken off, and another module of the same way can be added, which would look a little bit like this then. So all these modules, they would have the same kind of rooms inside, a connecting corridor. That means you can walk through the whole habitat without passing all these rooms, which is a very important thing. Then we can close some of these rooms for different missions completely. And of course, in a very far future, we can add more and more modules, which would look like this. This design was thought to be built on a submersible barge, like this La Chalupa habitat, which is now Jules Undersea Lodge. It would be, therefore, like a semi-permanent habitat. We can take it out of the water, it would float by itself. We can tow it to another place, again, like Jules Undersea Lodge. It would be modular. It will have standardized docking collars. We can add more and more modules on it, even if they look different. The docking collar would be standardized. We will have, if we're thinking about habitability, we will have a rectangular rooms. We have this corridor, we have social spaces, and we have some biophilic design even with maybe plants inside, or and of course there will be some serial production, which is an important factor. Means we have one design and we can take the approval for it one time, and if we have the second design, it will be cheaper by the planning, by taking the approval, and by adding it to the rest of the construction there. The whole thing was supposed to take place in a development park, that we have one fixed place where we say, here we try to develop this kind of habitats, here we try to bring other habitats to the park, add them to the main structure. In 2018, I was joining 2 symposia, and I introduced this kind of design, which we called like an underwater ISS. And I really think this is the only solution that, if we start to do something, this is the only solution that we can continue it, to make it bigger, to make it larger, to make it more durable and sustainable, I think. We proposed this design to the European Space Agency, which in the end was not accepted. But the positive part of it, we met Peter Weiss during this procedure of proposing it. And Peter Weiss, as I said, was the leader of the diving support team at the European Astronaut Center in Cologne. And he agreed in most of these features that we need a habitat which is modular, where we can add other modules to it. But he has a second design, which is, of course, different than our design, but in common, both have that we can stick them together. We have the standardized docking collars, we can put them together. And if we think of this development part, we can have the main structure there, 1 or 2 mobile habitats. They can be brought wherever we want, and they can be brought back and locked to the main structure again. As I introduced Peter already, maybe we can just switch over to Peter, who will talk about the possible relation between the new space sector and hydrospace. That hydrospace keeps some advantages for astronaut training and so on. And I'll just give over the word to Peter. Maybe you can introduce yourself 1 second and then just go ahead.
Yeah, thank you very much, Martin. I will share my screen right away so you can see my presentation. So as Martin explained it, we had already some exchanges in the last month about this idea about future habitats. As Martin presented, we created Spartan Space not very long time ago. Actually, we celebrated our first anniversary only 2 weeks ago, and the idea is to work on habitation systems for space and habitation systems for underwater. I personally have always I always swam a little bit between both areas. I have a background in robotics, in space robotics, but was also working a long time in underwater robotics. And actually the idea is, well, I'm convinced that there are enormous synergies between both sectors, and these can be used. So technology that is developed from for one sector can be transferred to the other sector. As Martin said, I was working before creating Spartan Space. I was working in a company called Comex for 10 years, where I was in charge of the space department. We were, beneath many other projects, we were also in charge of the diving support of the European Astronaut Center. So that's what Martin said, lead of the diving support in Cologne. That's where the European astronauts are trained underwater. Martin asked me to make an overview on the links between space and sea. I know from many people that are present here today, they are convinced about these links and these synergies. I tried to make it short. It won't be exhaustive, by the way. I think I cannot show everything. But the idea is to show a little bit what our thinking is there behind, and then also, as Martin already started announcing, showing a little bit what we see as the future. So exploration starts in the oceans. For me, I mean, we are a species of explorers. This started already many years ago, and is continuing like that. And there are obviously very nice synergies and very nice similarities between space and underwater. Everybody who does a little bit of diving knows that this feeling of weightlessness can be very easily reproduced, and that's, by the way, the reason why astronauts are trained underwater, because that's one of the simplest way in order to make them acquainted to working in weightlessness. We have in this frame with comics at the time performed missions in the past. Then was a nice mission called Apollo 11 Under the Sea. That was in 2014, I think, and we simulated with French astronauts Apollo 11, but on the seabed in the Mediterranean here next to Marseille. This is not new. Astronauts are trained underwater, as I said before, in many places, in Houston, Moscow, Star City, and of course in Cologne in Germany for the European astronauts. Doing it in the sea is quite challenging, and there's a fantastic facility that I think most of you know is Aquarius near Florida, where NASA is already performing the extreme environment mission operations, NEMO. So with astronauts and scientists being in this habitat offshore the Keys. We had the chance with Thibaut, who is also present here today, to participate in the last, it's not the last, in the trials in 2019, I think it was, just before the COVID. And in the frame of a ESA project called LISA, that was on testing and training and simulating rescue methods for an astronaut crew on the surface of the moon. So they are, what you see here on the picture, they are not in weightlessness, they are actually in 1/6 gravity, like on the moon. So you can also simulate lunar missions underwater, of course, very nicely. And here I want to go a little bit back in the past, and Martin already said Jacques Rougerie was supposed to be here today. Unfortunately, he couldn't make it up, but he asked me to show also some of his developments in the past in underwater habitats. As I said before, that's exactly what we are interested in, is this link between the sea and the space, and habitats that are developed for underwater might also give an inspiration for lunar or space habitats, and technology can be used in those. So here's some examples of developments that Jacques did in the past. So that's Galatea. There's another one, a very nice one, is Hippocamp. These were all smaller habitation systems that were built, deployed, and used. And by the way, there's Joël also here in the call, I think, that might also be able to give some more information on these projects. Another one very nice is Aquabulle. That was recently, by the way, used again, and I think it's maybe one of these, the right photo here, in Marseille. So it's deployed and is still in use. It's a very nice small habitation system that can be used for mission simulations. Now, I'd like to give a very brief overview of the next step in the space exploration, try to link that and back to underwater, of course. So the next steps, at least from US and European point of view, is Artemis mission, return to the moon, like Apollo. The Russians and the Chinese also want to go to the moon in the frame of what is called the International Lunar Research Station. So there's a general elan right now to go back to the moon, which is very good, by the way. And by the way, this is also something that's important for me. It's there's, from my point of view, really no concurrence between this kind of exploration and maritime exploration or undersea exploration. On contrary, there are really nice synergies, and this new elan in returning to the moon, I hope, will also lead to a new elan in starting underwater habitats in the future. So Artemis returning to the moon, that will happen in several steps. We'll start with orbital stations, then short duration habitats. The orbital station, by the way, is already under construction. That thing is called Gateway. It's built by the US and with some European modules, in which we are also a little bit involved. So this is already coming. Then come the missions on the lunar surface, and here we will most probably use short duration habitats or secondary habitats. And just to explain it very quickly, the idea is that the US will land on a specific place on the lunar south pole, that you see here on the chart. But they will search for places that are safe to land, basically, which are these blue spots here on the surface. These are places where the slopes are very, very little, so it's safe to land a human landing system there without risking the crew. But these spots are too far away from the spots of interest, which are the red ones and the yellow ones, which are places where you have lots of energy, the yellow ones, or potentially water ice, the red ones. So the idea of this secondary habitat is to be placed in a robotic manner on the lunar surface and surface base camp, if you might say. Like on going on Mount Everest, it extends the radius of intervention of the astronauts. That's the idea of this kind of habitat. So we are building right now, we are working on that here with Spartan Space and other partners, the French CNES, for example, on this habitat. It's quite a big machine. It's 7 meter in height and 7 meter in diameter. So you can see here a comparison with the Apollo lunar module that landed on the moon. So it's quite the same size, but much bigger volume. And most important, it's an inflatable. So here you see one prototype that we had last week in Abu Dhabi. So that is obviously not flight hardware. You shouldn't go to space with that. But the idea is having a platform for test. And one important point is the inflatable. Keep that in mind, because I will come back to that later on. Well, and then after the short duration habitats, which will be in the 2030s, then much later will come long duration habitats, maybe a lunar village that allows astronauts and researchers to live permanently on the lunar surface. And here I'd like to draw the link to the maritime habitation system. So another project that you might have certainly heard of from Jacques Rougerie is Sea Orbiter. That would correspond to an orbital station. Might it the Gateway here, or might it be the ISS or any future stations? So it's a system that is floating through the oceans. It's permanently crewed. It performs non-stop science, and as I said, it's not anchored on a fixed position. It's orbiting, like the name says. This project is already existing since quite some years. Jacques is pursuing this adventure since many years already. Very recently, last week, he got quite some support from the French government for that project. So I'm actually very optimistic that finally we'll see a Sea Orbiter orbiting the seas. Then for the short duration habitats, we could imagine something like I showed before, a Eurohub but underwater. that graphic is not made by Jacques. You might see there's a difference in quality. It's just to illustrate the idea. The idea is to have something that can be, that is mobile. It's not permanently crewed. And so it can be placed on the seabed for a specific mission, be retrieved, and be brought to another place in order to be used on another place. And then for long duration habitats, here I come back to another concept on which we work with Jacques Rougerie. It's what we call the International Subsea Village. So that would be a permanently crewed system, floating. You can see it's anchored, which has some advantages. And also one important thing, what Martin referred to as modular is it's extendable. The idea is basically that you have one hub that is acquiring all the energy and things like that you need, and then this can be extended to a certain extent, of course, by additional hubs that can be built around. So really, in the idea of a village that is growing over the time. It's not built from A to Z right from the beginning. So I will conclude my presentation with underlining what Martin already said. The idea of the development of a mobile subsea station. We were thinking about something that could be based in the Mediterranean, can of course be applied also to other places. The idea is really having something that can move around, it's not if I might say, a property of one nation or one institute, but that is as an object of federation. And as Martin explained before, the idea is having something that can really reply to the aspect of mobility. That is very important. That you can use that system for archaeology site, maybe for some months. Then on another side for marine science, then maybe on another side for space simulation and leisure and things like that. So the idea is really having something that can be moved around. The concept you see here is just a very first draft, let's say, that is obviously inspired by our space habitat, simply due to the reason for space simulations that would make sense. And we also think about using an inflatable in order to tackle the aspect of transportability. And that is what I wanted to say. Thank you very much.
No, thank you, Peter. That was very interesting. And when we talked about this proposal for the European Space Agency, which is with the modularity, we had in mind to have some kind of a European underwater research center. Do you remember that? We said if we would make it in European waters, there are incredible countries around it, a large number of countries, and there would definitely be some steady usage for it, I guess. So this was the whole idea, and especially I would like it if it would be all modular and could be under one roof. You know what I mean? And we have a mobile solution, we have a semi-permanent solution, and that would be the best thing. There
Absolutely.
Sorry.
I see it like a platform, like the system that we had in Abu Dhabi. It's a platform that can acquire some technology. Might it be for life support, communications, robotics, things like that. And if you have such a system, and maybe even several of these kind of systems, you can very easily exchange also technology between one and another. Yeah. So what you just said before, the aspect of reproduction is very important.
Right.
So I totally agree with you on that.
So I would like to ask, there was Miroslav Rozloznik, who's analog astronaut as well. Can you hear me at the moment?
Yes, I can.
Perfect. I wanted to ask you, about what do you think? How could a habitat like this could be used for analog missions? Do you have any comment on that?
Yeah, I think definitely. Definitely it can be used as a tool for analog missions. Yeah. So my answer is yes. Very, very quick and simple.
Okay. You were joining anyway one in Czechia, right? In the Czech Republic.
Yes, yes. Last year I joined Hydronaut project, and I was an aquanaut on board during the mission 2, and
Right.
I was also scientist on board. I was performing a lot of experiments on us as a crew underwater, and currently I'm preparing for the next mission, which should take place in August this year.
What's the difference between an analog mission on land and underwater? I mean, like, what do you think about that?
Well, there is the most distinguishing feature is that underwater we can use this phenomenon which is called saturation diving. Of course, we all know what does it mean. So basically, entering divers or aquanauts in saturation basically mimics the psychological load of limited rescue options and limiting options to, or let's say, delayed access to surface. So this is basically what is currently missing in other analog missions, which usually take place in different environments. Some of them, of course, in extreme environment, but still you have this, let's say, advantage or luxury that you can open the hatch and you have something to breathe. Underwater, you cannot do that. So it basically creates another psychological load to participants. And this is very interesting to study from the human factor perspective, especially during the long duration missions and confined space, etc., etc.
I just counted some weeks ago how many space analog initiatives are there at the moment. I came to 22. So I think that's quite a number. I mean, and I think there's a real how can I say, a real demand for real space conditions, isn't it?
Yeah, definitely. I mean, there are definitely a lot of analog mission platforms, let's call it in this way. Of course, some of them are high fidelity. For example, recently in October, there was a mission organized by Austrian Space Forum called Amade 20, which took place in Israel in the desert, which was very similar to really conditions which we might experience on the Mars, including, let's say, communication delay. What is also another factor which is influencing the procedures and the whole operability of the mission. So yeah, some of them are, let's say, lower fidelity, some of them are very high fidelity, but definitely underwater analogs are the most comparable from my perspective to the space conditions.
How are they funded on analog missions? This is what I was curious about. I mean, do they have some kind of a national science budget, or do they have private sponsors, or how does it work?
There are different models. Some of habitats run on or let's say participants' fees. So basically, the participants pay to be part of such a mission.
I see.
Some of them are funded, let's say, by grants, by sponsors. So yeah, it really differs from case to case.
Okay. Thank you very much. There's Omar Alayli as well, who's a space architect. I mean, maybe you would like to say something about the similarity between space and hydrospace?
Yeah, can you hear me?
Yes, very good.
Awesome. Hello everybody, and thank you for having me here. I would just like to just point out that in 1964, Jacques Cousteau did the Conchelf underwater habitat, while only in 1969, Apollo 11, Neil Armstrong landed on the moon. So from my perspective, I would imagine underwater habitats would be more advanced and more available and accessible than space travel and space industry. So from my experience, like the experiences and technology of space architecture and engineering are, I believe, very much transferable to underwater research and habitation, because most of the conditions, except for the pressure applied on the habitat, are almost the same or in the same level of equalness, where we still need a environment and life support systems in space, which we would need also for long-term underwater habitat missions. The structural analysis of the actual habitat in space and orbital stations are also, for now, similar to that of the existing habitats under the water, which, because of more astronauts and more analog participants are required over the next couple of years because of the increased missions into space, especially with the Axiom space station, which is going to be added to the International Space Station. What the work that Blue Origin and Lockheed Martin and Virgin Galactic are doing, all of them are building more space habitats. That means we're going to have more astronauts going up into space and working. That means we need more simulation habitats, like Peter and your other guests just mentioned. So the habitat, underwater habitat, is going to be a blooming platform for research and for training astronauts. And I think it's a good idea to participate and develop this industry. And yeah, so basically that's what I wanted to say.
Yeah, thank you very much. Yeah, it's a very interesting analog, I think, between space and hydrospace. So let's see what the future brings there. I think I just get over to the next subject, which I call specialized tourism. I spent 25 years in the hotel and tourism industry, by the way. So, and we really tried very different things, from very ecological tourism to mass tourism. If I talk about specialized tourism and undersea habitats, I don't want to be misunderstood there. I don't want to turn this into some kind of a Disneyland or something like this. But somehow we have to generate financial sustainability. So if we have scientific missions or analog space missions or archaeology missions, there will be always sometimes in between where there won't be any missions at all. So maybe we can make a program one day where we open any kind of future habitat for tourism. That doesn't mean that I want to bring untrained people into a saturated condition. It would be really difficult, of course. There are some alternative aspects, of course, in tourism. So we have actually 3 different scenarios. One of them is a shallow habitat until a depth of 9 meters, which is like Jacques Undersea Lodge in the Florida Keys. Guests can get in there, stay for a very long time. If they want to get out, they can get up to the surface nearly without an obligation of decompression. If we have an ambient pressure which is under this 9 meters, then we come to the saturated condition, which is very difficult, of course. If you have somebody untrained in a saturated condition, that would not be it, actually. And we have another concept which was proposed, for example, by Phil Newton, who said that actually we can have habitats in deeper waters which are under surface pressure of 1 bar, and we have to bring them then through submersibles docking to that station. You know, the last version is very unlikely that's going to happen, but the first 2, they are happening already. We have Aquarius, people are getting into the habitat, stay there, and they decompress in the end of the mission. They also have guest programs, let's not say tourists, but if you want, you can enter Aquarius and stay inside. And the shallow ones, of course, we don't have to talk about that. Jacques Undersea Lodge does it since many years, and that's quite successful. But what I want to take the attention to is something that beyond people getting into the habitat, stay there for several days. Of course, with an idea in mind to generate enough financial background to keep it sustained, the underwater habitat. Let's say 2 months in a year or something like this. we could have some kind of an activity zone on the surface, which looks a little bit like one of these circle fish farms, right? With a glass bottom platform. There could be boat tours, snorkelers, free divers. We can have diving excursions into the vicinity of the habitat. And we can even have short visits into the habitat if it's on 20 meters. Let's say 10 minutes to go to the habitat, 15 minutes, 20 minutes stay inside, 10 minutes getting out again. Of course, in the future, there could be some overnight stays, but as they do in Aquarius, there's a very serious training and drilling. It is obligatory, that which pushes up the price, the rate, of course. And I don't know if that's really generating some financial background then. As I said, we can have different tourism periods between missions. There's the merchandising factor, of course, that if we have any structure underwater and we open it for 2 months for tourism, there can be some kind of a merchandising program. If we open it for tourism, there's another advantage that we have. We should design the whole habitat more attractive, which we said we can say like a scenario, you know, like if it's futuristic or if it looks a little bit like a Jules Verne structure or something like this. And of course, there would be benefits for the region. Like 2 weeks ago, we had a meeting with the scientific committee of Malta. And I was thinking if we have this development park in one of their bays or something like this, that that would be also a big advantage for the region as well, that they can advertise with with a character of innovation and technology and stuff. So even they can attract guests to their location without that they even come to the habitat. But again, want to emphasize that tourism, I don't think tourism can be a primary source of income for this habitat, but it can support it very good, I think. So we should think about it and not say, yeah, we make a scientific habitat or we make a tourist attraction. I think we can combine them both, and like that we can guarantee that that we have enough income to keep it sustainable. Whatever we do, mobile habitat, a larger station, permanent habitat. This is what I wanted to mention about tourism, because everybody thinks every time, yeah, it's just overnight stays, but actually there are so many things around overnight stays or apart overnight stays, which we really should keep in mind. And it would be very helpful to implement it into the design, of course. There should be Ian Koblick at somewhere here around. And Ian Koblick is the manager, or he owns the Jules Undersea Lodge in the Florida Keys, which was the La Chalupa habitat before. And into this habitat, they implemented all kinds of very interesting design ideas. It was self-floating. It was submersible. It was towable. They could tow it directly to another place. And I think it's still one of the most, let's say, holistic designs of habitats. If Ian is there, I would really be happy to hear his idea about habitat tourism, maybe.
Well, thank you for all the complimentary things about La Chalupa. It is probably the most sophisticated in its design habitat ever built. And you know, it had some other features that aren't well known, but it was because we were operating in a remote area. It's designed to jack itself out of the water and for servicing. So it actually sat about 3 feet out of the water on hydraulic legs. Also, when you deployed it, you didn't have to have a flat surface. You sent it down to the bottom. It took about 45 minutes to an hour to tie it up on site and then lower it. And once it got to the bottom, you used the moon pool as your level bubble, and you just changed the hydraulic legs until the habitat was totally level. Some great features, because leveling for habitats has always been a big job.
I think you had these hydraulic legs there. That's as far as I know, it's true. Yeah, I didn't just understand correctly, but if you
Yes.
put it down, you could adjust the legs about it. That's a very good feature, of course. There were some other habitats. They stayed for the whole time of the mission in a slight tilted way, which was very disturbing as far as I know. What do you think about underwater habitat tourism? I mean, you do it since many years with tourists in the habitat. What do you think about it? Is that an alternative to get some financial background for operations?
I don't believe that a habitat that you have to dive to will be successful as a tourism attraction. I think that in order to make it successful, you have to have special events and special programs
Yes.
that attract tourists. And I'll give you an example that I am right now putting together a marine archaeology program where the participants will live for 48 hours and become saturated. So that'll be a big thing in their logbook. And they will carry out marine archaeological investigations. I have a ballast pile from a shipwreck. I have cannons and anchors and amphora and a sunken city in our lagoon. And I believe that this program is going to attract a lot of young divers as well as older divers. And it will be quite busy. I would say that our occupancy is probably 8 to 10 people a month, and we've been doing it for like 35 years. So, and you've seen that we've had hundreds of millions of dollars in marketing, promotion, advertising, articles and TV shows and so forth, and it still hasn't made it profitable.
Nice.
If you had a habitat that had a surface access, but appeared to be an underwater habitat, and you actually had a diving facility at the surface level that was part of the habitat, I think that would draw a lot of tourism, especially if you had a dining room there where people could come out and have dinner and enjoy and go back to shore.
That's true. It's like at Maldives Islands, there is a very well-known hotel. They made the so-called ITA underwater restaurant, which is a tube. Half of it is transparent, or the upper part is completely transparent. They spent $5 million to produce it, and I was actually thinking how many people have to go there and eat their dinner before they return their money. Of course, it will never happen, but they did it. I mean, they didn't return the money, but they did this restaurant, and of course, not that they get the money returned by selling the food, but that people hear about that restaurant and they come to that hotel just to see it, or just to. So it's a magnet to attract people there, and $5 million for a restaurant is, well, I think they have like 25 people capacity. That's quite a number.
Another way to turn the habitat into a profitable tourism attraction is to have it in association with a hotel.
Right.
So that the hotel guests come, they spend their money in the hotel, but they have an opportunity to spend a night or more in a habitat that's very close to the hotel, within, a couple of miles of the hotel or even closer. And that way you have a built-in customer group that's already there and attracted, and there's part of their package.
Right. Perfect. Jan Koblick, thank you for joining. I will come to you back in a short while, because when I ask all the other pioneers again in the end of the conference, I would really love to hear your opinion again. So we just get on to naval architecture and the technical advice. We have Michael Schutte here, who's the designer of proposed Poseidon Resorts, which was, you can say it by yourself maybe. Okay, Michael.
Hi. First of all, thank you, Martin, for inviting me here, and second of all, I'm super impressed with the legendary cast you've managed to put together here. So it's a pleasure to be included in such exalted company. I don't deserve it, but yeah, my name is Michael Schutte. I'm a naval architect, and most of my life I've been designing yachts, but there are a lot of yacht owners who also have enthusiasms for going under the water, and increasingly we're starting to see submarines on yachts today. You know, people like Triton and are instrumental in getting people interested in this stuff, or not interested, but giving them the ability to actually go and do it. So over the years, I have been involved in quite a few underwater projects. Starting with a sea room back in the early 90s, which was an owner who wanted to have essentially a container with windows in it that you know, submerged so that he could have an underwater living room, and that's kind of where it started, my involvement in this stuff. And you know, we all thought the guy was crazy, but it was an interesting idea, so we kind of went with it. But I put together a very short presentation on some of the challenges and the considerations that the designer or the owners really of any underwater habitat have to think about in the process. So I'll share my screen with you here and just kick off. And I'd encourage everybody, by the way, to just shout and stop me if you have a question. I've only got 4 slides. I'm going to try and go through them quite quickly. Just I suspect that people are going to have comments and questions. So just please just shout. And here we go. I'll share my screen now. Construction and assembly method is design drivers. So one of the problems we've had, I'm showing Poseidon here because this is probably the most extreme example, and so some of the constraints we had when designing this from the beginning were, how are we going to transport these various components from the construction site, which was nowhere near the deployment site, which I think is absolutely typical. You're unlikely to find a huge shipyard next to the glorious coral reef that you want to exploit in this case, or your archaeological site. So we were constrained by the largest heavy lift ship that we could use to transport these components from the west coast of the US, where they're being constructed, to Fiji, which was the location where this proposed hotel was going. So let's go back to the top of the slide. You know, where are you building, and what are the abilities and the logistical constraints that's going to impose on the design from the beginning. And that, yeah, absolutely, the maximum component size and weight is one thing that will drive how your pieces are going together. Now, Martin talked a little earlier about standardized connection collars. And that is absolutely critical when you're looking at something like Poseidon. So assembly and deployment then will be one of the major drivers on your structural design, just in terms of how you put the thing together so that it can be reassembled on the site. And here I'm showing a couple of images of Poseidon. Now this was intended to be a huge facility with 24 rooms and a bar and restaurants and a hotel reception and conference suite in the other end. And I've got another image of some of the interior of this later on. But essentially, the idea was that each piece would be neutrally buoyant, or as near neutrally buoyant as possible as it was deployed. And that kind of imposes both fixed and variable ballast issues. Each component is massively heavy. I mean, these were mostly constructed out of 25mm steel, so they're more like boilers than hulls. But again, this was a 1 atmosphere habitat designed to go at 15 meters underwater. So there was a bar and a bit of well, actually the bit, because you take off the 1 bar of the internal pressure. But as the thing was being deployed, some of the loads on this are much greater. The racking loads, for example, along the torque tube in the middle, was a big issue. So all of these things kind of contributed to the fundamental design in the first place. So I'll just move on to the second slide now. The second big thing that needs to be considered is your mechanical systems and how much autonomy are you designing for. again, most of my experience is with one atmosphere habitats, so there are some special challenges associated with those that aren't necessarily going to be the case with ambient pressure habitats. But nonetheless, the first, the three of these are going to be absolutely critical. And so where's your electrical power coming from? Because you are going to have many consumers inside a space that people are living in, from not just, from cooking, but also the toilets are going to be electric. Your HVAC system, whatever that looks like, scrubbers or air changes, all of this stuff is going to have a huge electrical draw, particularly if there's pressures involved. Your water systems, you have fresh water that's required, you have gray water, which is dirty water from sinks or showers, and then there's black water, which is light gray water but with lumps in it. And you have to have systems to move this stuff around or to store it. And again, that is going to affect your ballast conditions. Now, once the thing's on the bottom and it's actually bearing on the bottom, then it's not, you will over ballast so that you're stable down there. So it's not necessarily a huge problem when you're on the bottom, but in transition, all of these things need to be considered. So if you have a large amount of fresh water on board the thing, you can make water too with water makers, but then that takes us right back up to the top again, which is electrical power. So all of these things will drive the complexity of the habitat that you're trying to build and have implications on how you provide these various services or fluids or remove them or whatever to your habitat. So they either have to contain it, or they have to eject it locally, the waste, which is going to be unpopular in many places and illegal in most. So these things have to be considered. So the location that you're intending to put the habitat will have some bearing on this. But if your intention is to have a habitat that can be used in many places, then you're going to have to design for the worst case from the beginning. And all of these things are actually contributing to how you're going to go and build it, and we'll come on to that in a second. So we spoke a little earlier. Many people have spoken. I mean, Ian was particularly enlightening in terms of his insights into how to make something like this profitable. And the one atmosphere, I think, is key to allow civilians to come and enjoy these habitats. But the implications of that are that you're going to charge them money. Which means you are automatically dragged into liability issues. And the way to defray the risks of liability of somebody having an accident or dying for any reason or getting injured for any reason in your facility, you have to design for safety from the beginning. Now, there are many relevant semi-relevant standards, shall I say, that you can apply to try and have a positive conversation with your insurers. Now, PVHO, which is the Pressure Vessels for Human Occupation, which is an ABS standard, the American Bureau of Shipping, has many ideas about what you can do to make an underwater habitat safe. Now, these again, it's more relevant to submarines probably than it is to an underwater habitat. But again, there's lots of lessons in there and mitigations that are designed in to make it a safe thing. U.S. Coast Guard or other statutory safety bodies will have requirements in terms of how you ensure and provide safety for your guests. And then the Marine Coast Guard Agency is another one, more European-based. But they have very detailed rules about what you need to do if you're going to charter your yacht to a private customer. And that duty of care is very similar to what would happen if you took money off somebody to introduce them to your habitat. So these are all things that, again, will influence the design. Now, there are also land-based hospitality rules and regulations. California is particularly stringent, and when we were looking at the design of the Poseidon Resort, in fact, it was slightly earlier than that with another project that these first became available. But things like having two separate routes of egress. So if there is a fire or some other kind of accident that closes off one of your exits, then it's absolutely critical that you have a secondary exit from every space for your guests. And if God help you if they die in your facility because they couldn't get out, because the quite apart from the tragedy, it's going to shut you down. It really is a huge issue. So with Poseidon, and if you look at the image on the left here, now this is the structure of one of the pods. Now we had, we featured cell cast acrylic slumped windows quite heavily in this thing. So they did perform, they were a big part of the structure. But I'd like to draw attention to the two little blisters on the top of the back of this pod. And now what that is like a refuge. So if one of the windows broke, for example, somehow in these pods, the water is going to fill the space up, and yes, it will go hyperbaric depending on how deep it is. But there's a little refuge for people that they can float into this little thing, and then there's a seat around the bottom so that they can sit there and use oxygen in the space that's there already. And clearly alarms are going to be going off all over the place. And then the one adjacent to it on the right-hand side of the picture is a diver access. So that's a hatch that can be opened from the outside. And that means that you can send a diver down to rescue people who are trapped in these pods, should there be some kind of catastrophe with the individual pod. Now, if you look at the one on the right, you can see that there's an airlock between each pod and the spine that runs through the whole facility. And that, again, allows you to isolate this pod should there be an accident in it, because you cannot open both of these doors at the same time. So even if, so it's impossible for that pod to flood. You'll also notice the orientation of the watertight door on the inside means that if that pod is flooded, you will never be able to open that door, right? So, and then this is the restaurant and bar area. So you have the entrance to the spine here, but in each end of this facility there was a column that went to the surface that contained an escape staircase, the elevators for standard getting in and getting out, and then it was a double helix on the side, one that had an escape staircase, and the other one contained all of the piping and wiring, services that needed to get from the surface down into the facility. Now, this facility was not creating its own electricity. It wasn't creating its own water. It wasn't creating anything. It was just consuming. And the concept behind this was that the hotel on the island, which this was a daughter of, would provide all of the services required, including pumping out the waste and everything else. So our responsibility with this was just to create a way for these to get in and out, and think a little bit about how we were going to move things like Blackwater with vacuum systems where you only have one bar. So you have to think about stages where you can, depending on how deep you are, you can only lift it by the 13 meters, right? So this the void spaces for services and everything else were a major consideration in the design of this facility. You can see in the pod here, we'll come on to ballast systems in a second, but each of these pods had a fixed ballast under the floor, and you can see the openings to be able to get in and pour this ballast is, and it was essentially it was concrete and shot, but so the volume of the bottom of this pod is exactly what it needs to be to contain the ballast to offset the air that's inside it. And again, one bar, so each of these things was neutrally buoyant as it was deployed. Now you need a bit of a crane to get it actually into the water in the first place, but once it's there, it's pretty easy to move around. And then there was a variable ballast section that would let, there is some water ballast in the bottom here that allowed it to become negatively buoyant as it sunk.
What's the negative ballast? How much?
On these ones, because they're very stable, it was of the order of sort of 15%. And if we go back to this original image, the idea with these was that they would be lowered into position by very small craft. So you haven't got like a huge 1,000-ton-meter crane in Fiji to be able to do this. So but like the large components were delivered by heavy lift ships that were able to deliver them direct to the water. But these pods would all have been deck cargo. So they would have to be launched individually and then floated into position. So in this case, because we had a very, very good, very low center of gravity, the requirement for the fixed ballast was limited. Sorry, the variable ballast was limited. But in the case of the larger pieces, then that was very much not the case. There was a huge amount of variable ballast in it, just for safety, just to keep them the right way up as it was going down.
Also, storm protection. You know that we've had some real damage to offshore structures underwater during the hurricanes and storms.
Again, that comes down to your depth, right? And if you think about the washing machine that is every wave, it doesn't go up and down; it goes around in circles. And Martin's design with the fairing that disappears into the bottom in every case is a good idea to mitigate some of that. But you're right; once the pieces are all connected, then absolutely you have to have a much more robust anchoring scheme than just the few tons of dead weight that you have under the feet. So that's a very valid point here. And this all the reason for all of this song and dance and the potential pitfalls that I've been trying not to describe as such, but clearly are. This all comes down to setting your design brief in the beginning, with not just with your architect. The architect isn't the only person who's interested in this. Ultimately, whoever's funding this program is going to need to be convinced that you're going to be able to deliver your product to its location in something resembling the time and budget that you pitched in the first place. So my strongest advice to anybody who's setting out to do anything like this is to be very clear about what your mission profiles are, and try and limit the wouldn't it be cool ifs, because that stuff is going to kill you if you don't design for it in the first place. So be very clear about what your mission profiles require, and then be absolutely specific about what those requirements are. So I require X liters of fresh water per person per day who's going to be in the space. I require cooking facilities that look like this. Is it a microwave? Is it a 6-burner gas stove with a barbecue next to it? All of this stuff will have huge implications on your services, on your HVAC, on your air changes, on all of the stuff that is going to define the quality of the environment inside. So all of this stuff leads into your set of contract specifications with your builder. I mean, once you have your design put together and you're going to build, be clear that the builder is a commercial operation. If anything goes wrong with your design or your build, you will pay. So changes are going to be a huge problem. They will cost you money and they will cost you delays. With the larger the organization that's building the facility, the more likely they are to have very robust contractual devices that punish you for changing anything during the build. So it's critical to have a very, very well argued, very detailed a set of contract specifications supported by all of your investors and agreed to by the shipyard or the facility that's going to do your building, and then you have to stick to it. And that kind of takes me full circle. I mean, I can talk a little bit about some of these projects that I've jetted by, maybe. This one, and again, going back to Ian, this thing was actually designed to be deployed in the Keys to support a tourist submarine. So the idea was that this facility, a couple of problems with tourist submarines: they're not very fast and they're very expensive to run. So and what people want to do is they want to see Pirates of the Caribbean. They want to see the pirate's chest. They want to see the coral. What they don't want to see is an hour-long 3-knot journey on the surface that makes them sick. So the idea for this thing was that it would be towed out to a convenient site that was close enough to the interesting item, whether it's the reef or wrecks or whatever. And then a fast boat would go from the port and deliver the people to this facility. Now, included in this facility are a bar and a restaurant on the lower level. There are, on one side, it's a catamaran. And on the other side, there are 5 duplex hotel rooms with an underwater bedroom and then a living room upstairs with a balcony. And on the top deck is a snack bar and bar area. And there's a dive shop and there's a tourism shop, Mother Teresa in the shell sort of stuff. And all of that stuff is there to support the tourist submarine operation. And then the tourist sub just does little circles. They pick people up in the middle here, take them to the dive site wherever it is. So you can do 30-minute dives or 45-minute dives instead of 3-hour dives, which means you're maximizing the utility of your sub. And by the way, you've got a captive audience waiting for their sub dive who are going to go to the gift shop and they'll eat a hot dog and buy a treat. So unfortunately, like many of these projects, it died in its infancy. We did do all of the design and engineering for this thing. It's made of steel. And the ballast system for this one was interesting because this, again, it had to be towed to site. And what we did with this was, if you can see, it's not a very good image, but you can see that there's kind of a black band that looks like a bumper around the bottom. And what those were individual cast iron sort of ears that clipped onto a rail. So the thing would be put on site, and then you would ballast it incrementally to get all of the bar and restaurant underwater. But it meant that you weren't towing something that required 10,000 horsepower to get it to and from the site. So yeah, you're on mute, Ian.
Okay.
Were there permitting problems that they ran into in Monroe County?
One of the things that I think has been key to any acceptance by locals of any of these projects is a zero impact idea. So this thing, for example, it makes its own water. It holds its own waste. It has a sewage treatment plant in it so that you're just releasing clean water back outside it. But all of this stuff means that you can have it sitting on site. I mean, apart from the vessels coming and going and the pollution implied by them, there is actually zero impact to the site with this thing.
So it was very interesting with Poseidon Resorts there, and this is exactly what Ian said before. With for touristic purposes, it would be the only way would be to have a corridor to the surface where people can get down to the main habitat, let's say, and stay there. There would be, but at the same time, it's the conflict that I have seen all the time, that if we make a habitat for one purpose only, we will never find the finances to make it. So we have to make it interdisciplinary. That means like trying at least to make some touristic benefit from it. But if we have something with a corridor to the surface, then the scientific group would say, yeah, what can we do? I mean, we cannot get out there. There's no lockout and stuff, so we do our dives on the boat. So what I also, yeah.
Let me just interject for a second there. I mean, one of the really early projects that we did was that there was a Disney foundation, the Disney Foundation, and essentially they were interested in exploring ways of taking underprivileged kids and showing them underwater. And one of the fundamental parts of that idea was that you had a facility that could either be ambient pressure or 1 atmosphere.
Right.
And it was designed, you know, to a certain depth, clearly. But let's be clear, most of the things you want to look at underwater. So if I'm a tourist, I'm not interested in going to 100 meters deep because I can't see anything. It's dark, and there's nothing there. So really, most tourists want to be 10, 12, 15 meters maximum, where there's still lots of light and where there's critters to look at.
Right.
So that the two of them aren't necessarily going to fit into the same design unless you look at making the thing robust enough to have some kind of variable pressure inside if you want to do serial production. The other thing is you can make two that look exactly the same. And Eisner's idea, the guy from Disney at the time, was that he would have a village where some of these habitats would be ambient pressure for the divers and for people who wanted to be more adventurous, and the other half would be these 1 atmosphere habitats. They're still in the same community and still connected to the same dock structure above and everything else to get people in and out, but some of them would be pressurized. Now, if you go back again to your idea of assembling different components, if you have airlocks between the sections, then there's no reason why you couldn't have one part of the habitat at ambient pressure and one part at 1 atmosphere, and then a decompression chamber to allow people to travel back and forth, depending on, if the center section of the thing is just decompression and moon pool, for example, and you've got one atmosphere on one side and ambient pressure on the other, then it's up to the person who comes through that moon pool in the first place whether they turn right or left, and the implications on their decompression. How much hyperbaric life do they want? It does give you the option, but again, it just comes back to the original design brief and how much flexibility you want to build in there, being clear that any amount of flexibility is going to cost you money.
Right. But what I understood, we discussed several times already, but what I understood from it that, of course, there are many obstacles, but there are many obstacles for any diving center as well. If you bring people who you make a diving course to, you bring them underwater to 30 meters depth. Yeah. That's a real challenge, but there are some special ways how to fix it, and people can open diving centers. So I think even if there are many obstacles, they are not there to make us unhappy, but they are there to make people safe, right, underwater. And what I understood is from these side of the laws, how you say it, this legal issues, and from a technical issues, it's there's a way to come around and to do it really. To do underwater habitats. This is what I mean.
Absolutely, and the reason I'm bringing these issues up is that there are risks inherent in going underwater, and much bigger risks inherent in taking untrained people underwater. The idea of mentioning this isn't to pee on the bonfire. It's absolutely to make sure that any risk that is inherent in what you're doing is mitigated by intelligent design from the beginning, and that's just part of the brief that you have to give to your team to start with. Right. Is what exactly are the risks that we're proposing to mitigate here, and which risks are we not proposing to mitigate because it's not part of our core business.
Can I ask Liz Taylor as well? She should be here at the moment. You are also producing submarines, right? Like submersibles, let's say, for scientists, anything. You should really have obstacles there, right? You bring people down to hundreds of meters, and that should be really chilly under there, right?
Yeah, we have conducted submersible operations for many decades, and we find that people really do enjoy the experience. We've done the single-person submersibles all the way on up to 10 and 12 passenger submersibles, and for various depths. And the one key thing that we always keep in mind is that we will not be involved in any kind of experimental submersibles or home-built submersibles. So we always do make sure that they're fully classed and approved and certified, because the point that others have made, one accident can set everything back by decades. So we're very careful in that regard. We go with ABS, Lloyd's, or GL for class, depending on where the submersible will be stationed in the world and whether it's going to be on board a yacht or not, or other vessel. We did the first dual classification of a submersible for both research and tourism. And it was certified with ABS and another registry, so that we were able to have that duality, mostly to facilitate its position with the yacht. So there's a number of ways to approach this, and I think before you also had the question about, do we just replace people with ROV? And it's a completely different tool, and it's been famously said that you can't surprise a robot. So there's always going to be a need for human-occupied systems, diving. They're all just kind of different tools in the box, whether it's a diver, an ROV, an AUV, a autonomous surface vessel, whatever it happens to be. They're all different tools to bring to bear, depending on the circumstance.
What do you think? There should be more underwater habitats for human occupation, or what is your opinion about that?
Oh yeah, I remember as a little kid, there were dozens of habitats around, and now there's just like I can count them on one hand, and it's really kind of disappointing to see how little is happening in the space. I think that there's plenty of room for it. Certainly from the scientific community, there's a huge demand. It's been famously noted that, looking at the work of Jane Goodall, imagine if she had to study chimpanzees using sort of the habitat method, right? And had the kind of access that we've got with habitats to the seafloor, and working with the megafauna and just the day-to-day marine communities down there. It's a completely different sort of a situation. We need that direct working access, and to expand upon it, so that we can really compel people to care about the ocean, not just the surface of it or the beach or the coast, but top to bottom.
Right. Is there anybody else who wants to give any comment to this subject? Because this is a very good opportunity now. You have the right people here on board.
What I have, Martin, I'd like to go back just a little bit on the habitats.
Sure.
We actually designed for Ocean Reef back in the 80s an 8-room habitat that would be right offshore out by Carey's Fort Light. It was made of concrete, and you built it in a shipyard and then towed it to where you wanted to go, and then submerged it with its own ballast, both hard ballast and movable ballast. It had a dining room, 2 entrances and exits, and a diving area where you felt like you were going into the diving section, but really it was up at the surface and you just dived into a moon pool. But I think the concept of having both a lockout and one atmosphere habitat's a good idea, but you have to keep, in order to have those folks transfer, it has to be at 8 meters. 8 meters is the number for no decompression. I can swear that by tens of thousands of people we put through that number at the Jules over 35 years. So the hard part is to find a place in the world where that habitat is safe at 8 to 10 meters.
Right. That's very shallow. So every wave you should feel straight away there.
Yes.
It was very interesting for me that there was Aquarius, and there was just over a hurricane passing. And I said, okay, that's it with Aquarius, goodbye. But actually they did it very good there. And Aquarius is, I think, 20 meters deep, right? 20 meters something.
They sustained quite a bit of damage. They lost their surface buoy and they had quite a bit of damage.
Right, but to the habitat itself, nothing happened there, right?
Nothing happened there. However, even at 30 meters, when we were diving at 30 meters and there was a storm above us, your ears were clearing every 15 seconds as a 15-foot wave went over you.
Right. So if there's anyone who wants to make a comment on that subject, go ahead. Otherwise, I switch over to the next topic.
I'm Jim Miller.
Yes.
I was supposed to get some time, but the habitat's been designed.
Right.
Safety features covered.
I would be. Yes, please.
I've got some suggestions here, if you're interested in hearing them.
Yes, sure, absolutely.
Well, one thing is, I think we're all leaning towards having a safe habitat. They've had habitats historically made out of cement mixers, out of trash cans, and all kinds of things around the world. And there have been, roughly speaking, almost 70 undersea habitats built, most of which are no longer on the surface. They're only on the bottom. However, having a community set up, small as it is, as opposed to having a project, we all stay down for 2 weeks and then we come back up. Everything gets planned on a 2-week basis, which may not be what we need. So I would think, one thing, we really need to put some people down and leave them there for quite some time. And 2 weeks is not some time. I was down there for 2 weeks twice on the seafloor, and we were living and or making excursions down to 265 feet. And that doesn't make any difference when you're living at 105 feet.
So 265 feet would be something like 80 meters, right? 80,
Yeah.
90 meters, something, yeah.
Yeah. Now, what we were doing this for in this particular case is to see how far you can go down and what should be the rate of descent and ascent in getting there. So we were testing the limits of one of the things you need to test ahead of time to know, oh, you live at 105 feet. Well, that means you can go to 250 feet, stay as long as you want, come back to 200 feet, and no decompression.
That's true. Excursion diving, you're right.
And, I mean, this is not new news. So I think we ought to start thinking in terms of which people have already reserved to long terms. You could offer a program, in spite of the fact that it was recognized not to, where people go down, they actually put down a fish farm. You've got to have something to do while you're there.
Yes.
Just like the space program. But by the way, the space my home is in Melbourne, Florida. That's 20 miles from the Space Center. Let me tell you, the Space Center is very busy these days.
Yeah.
They're constantly launching. They're constantly involving industry and so on. And I think we should learn some lessons about how that came to pass originally. It took a long time. And with regard to visitors, if you set up, say, a community of, pick a number, 20 people, and they're down there and they've started up a fish farm, actually producing fish, not eating them, but make more of them. And so you've been down there, I think the record is about 2 months, 2 to 3 months on the seafloor at about 50 feet. Now that was done in Jan's habitat many years ago. But let's see, what was I going to say here? Oh yeah, one thing you got to get used to the fact, if you put down a group of people, whether it's at the North Pole, on a whaling ship, whatever, after they're together for a long period of time, they don't really welcome visitors. Visitors are interlopers. And I'm not saying that we shouldn't have them because it's a good idea. But we actually tested people, you know, what were your favorite things not to do while you're down there, say for a week or two. And the answer was basically keep the visitors out.
Sorry, keep the visitors out, right?
Because particularly at the beginning, because Cousteau passed the rule in Con Shelf 1 and 2, he was the only one that's allowed to make a telephone call back to the surface. Because what would happen is these guys would get down there and spend time getting suited up. They get all ready to go, and somebody calls down, "Hi, George, what's new?" And so they start over again. I think the technology got really a good look from the comments of your other speakers. All of those things that they suggested, they are real problems. And there are some problems that are particular to certain depths, certain times down, overconfidence, and stuff like that. On my two missions, and Jan and I were on those two missions. We had a close call on both of those missions. I mean, a real close call. I think my major comment, I'm cutting short here a little bit, but my major comment is I think we need to talk really long term, not 2 weeks, not a month. I mean, we have to include those missions for training and stuff. But I was down only about 2 weeks at a time twice, but I wasn't yearning to get back. I mean, I was very contented staying there, and the reason I came back when I did, and we planned it that way, not just for me, is our family said, "When are you coming back?" So it was family related, not mission related. Okay. And once we put that in the mission, because most of us were very content down there. There are things to do. There are fish to study. There's algae to study. There's other people to study. And it's the same thing with the space program. They've had, I don't know how many aquanauts have actually had experience in the habitat. I haven't been able to find that out. Well, it started off with staying down and taking training, and it turned out to be a requirement that astronauts have at least one program and stuff to do as aquanauts. And part of this was for physiological things and stuff like that.
Yeah. So your overall message would be that we should definitely work on getting new habitats underwater for longer periods of time, for longer periods of time stay.
That would be my recommendation.
Yeah.
And plan along. I mean, obviously, if you're going down to study a piece of technology, you want to know if it's going to work. You don't have to stay down there for a month to find out.
Right.
I'm not suggesting staying down just for the heck of it. But if you want to have a community, you better fix it up so that they all have things, as was mentioned by somebody here this morning. Make it like a community. Don't make it like a visit.
I heard that several times already, that people who stayed like 1 or 2 weeks underwater, like in the very lit area, who said that they wish they could have stayed longer underwater.
Yeah.
And this is a very interesting aspect. I think you have to stay there. I mean, I didn't do it, but I think you have to stay there to understand that feeling.
Yeah, I think so too. They've had long missions. They've had astronauts stay a year in space.
Right. And I'm very thankful that you brought up this subject with current space hype, which I compare a little bit with the underwater thing, of course. And if there wouldn't be like 2 or 3 actors who said, now we do it, nothing would have happened. We would have gone on like this, like it was before. But there are 2 or 3 private companies, they said, we want to continue, and suddenly the things started to move. And this is an interesting thing that happened these days, yeah. And actually, I want to try to use this momentum to shift it to underwater, that we say there's a demand for underwater habitats, for the space experience, for space analogs, for sciences, and we can do it parallel to the space hype at the moment. So this is what I'm trying to do at the moment, of course.
Now, I haven't been in space, but I've been underwater, and there's always something to do.
Yes.
In addition to taking care of the habitat itself,
yeah.
From a safety standpoint, that has to be number one thing.
Yeah.
Have we checked the dishwater? Have we checked these instruments and so on? That becomes routine.
Right.
But that's not what you want to go down there for. You have to have a reason.
Right.
You go down, except during the development of your project and putting safety devices and things. If you want to cut your mission short, send somebody down for a couple of days. And unless they want to just be able to say, I stayed underwater for 2 days. And that may be a eco-tourism. You equip somebody, they go down, they can go back and say, hey, I looked around and it was like looking outside at an aquarium where you were inside.
Right.
Everybody's experienced that.
Which is a little bit similar to the overview effect, which there's some idea about that people who go to space, when they look back to Earth, that they have a complete different relation to the whole planet.
Yes.
And I think that if you go underwater and stay there for 1 week or 2 weeks, I think you also get a different relation to the marine environment. That's why I think underwater habitats could be a very good tool for marine conservation as well. We should keep that in mind as well. Huh?
Yeah, I agree with you, because I'm the one that suggested to NASA that they use undersea stuff to test them in the first place, train NASA in whatever they needed to be trained in. And then they started using a pool and ponds and so on. Now it's routine. But they started doing it because it was cheaper to put somebody in a swimming pool, and so they will decorate the pool, have it nice. You'll stay down there for a day and a half.
Well, you know, it occurred to me that what Jim was talking about is a very important aspect of what you're looking at. And that is that you really don't have to go deep with your habitat. If you're at 30 meters, you can be on N202. And we had to dive on air down to 80 meters. And that our limiting factor was oxygen toxicity. But with the new rebreathers, which are really quite reliable, you can now reduce the oxygen in your rebreather, so you're higher on the nitrox, and dive down to 80 meters and work at 80 meters, probably half a day, with no decompression back to your 30-meter storage depth. And your habitat doesn't have to be on the bottom. It can be a suspended habitat.
That's true.
So that you reduce the entire cost by millions of dollars over time.
That's true.
That's what I wanted to do.
Yeah, I'll back Jan up, because if you're living at 100 feet, in a sense, that's your new bottom.
Right.
100 feet. So you can, from the surface with the scuba tank, 100 feet, you get down there for longer than 20 minutes and you have to decompress with the Navy table anyway. But if you're down at 100 feet and you just left 90 feet, you can stay down a lot longer.
Right. That means like the non-decompression space around you is growing the deeper you go.
I haven't thought about it in those terms, but that's correct.
Yeah.
And that's well known. Well, people have been staying down because Jan and I both stayed at, I think about the deepest was 250 feet. And we stayed there quite a while because we were taking tests, arithmetical tests and other stuff, memory tests and these kind of things. And we could stay at 250 feet, come back to stay 100 feet and no decompression.
Right. You said we need a reason if we go underwater, and that brings me to the next topic, which is underwater archaeology. I'm here in the Institute of Dr. Hakan Öniz, who is a very renowned underwater archaeologist, and I was talking with, and he appeared, by the way, to be one of my neighbors. I didn't know that. And I would like to hear his opinion about how underwater habitats could serve his sector, like underwater archaeology, or what is underwater archaeology anyway? I mean, how deep do they go? What are they doing? If you could just say some words about it, introduce yourself, and just if you could open your camera as well, that would be very nice.
Okay, can you hear me now?
Now I can hear you. Very good. If you okay, here we go.
Okay. And first of all, thank you very much for the invitation, and thanks a lot for this excellent presentations and excellent speech on the habitats. As you know, I'm an underwater archaeologist. Actually, I am not very aware on this new subject for us. First, I would like to start to talk on what we are doing, who we are. We have 3 departments on Akdeniz University, the Mediterranean coast of Turkey, focused to underwater archaeology. Not only underwater archaeology, but also underwater archaeological objects, restoration and conservation. We have labs, we have the institute who focus to master and PhD programs on underwater archaeology, and also the research center. We are already working with UNESCO. UNESCO, I was the coordinator of UNESCO Unity in Underwater Archaeology Network, which is established, found in 2012. Now this is the biggest organization under the umbrella of UNESCO on underwater archaeology. Now we have 42 institutions from around of the world on underwater archaeology. There is another intergovernmental organization named ICOMOS, International Council of Monuments and Sites. We have a committee named International Committee of Underwater Cultural Heritage. Probably many of you know there is a confederation named the World Underwater Confederation. And now CIMAS is more active on underwater cultural heritage too since about 2 months. What we are doing as underwater archaeology at the coast of Turkey, behalf of the Ministry of Culture, all over the coastline of the Turkish Mediterranean is under our responsibility. And what we are doing, we mainly focus to find the shipwrecks, about 1,200 kilometers coastline. Since about 11 years, we have found 321 shipwrecks from Bronze Age to Ottoman period. It means that 3,600 years old shipwreck, which is the oldest shipwreck of the world. And the others are about until 100 years old. For example, last year we have found 33 archaeological shipwrecks, mainly contained amphoras, and before last year it was 57. It means almost every day we found a new unknown shipwreck because our coastline is an extremely historical place, and some of them are from Bronze Age, like 3,000 or 4,000 years old at the left-hand side, or just 1,000 years old at the right-hand side. So the many wrecks, many anchors, or many other remains already found by us. We have enough technology to find the shipwrecks. We have already one ship. We have several ROVs and underwater communication systems and sonars, etc. And now we are using the high technological methods such as 3D dimension photoscan methods. When we find the shipwrecks, we are doing this technology. And until now, about 230 stone anchors from Bronze Age at this coastline. This is something for us because, you know, we need to find the past to understand the past. Okay, now we are able to show the Bronze Age roots at this coastline. And we have excavations too. This is an Ottoman trade wreck, which is from 1721. And we are excavating this. We have found excellent remains from the shipwreck. But most interesting excavation of us, this oldest shipwreck of the world, contained the copper ingots from the Cyprus Island. We don't know yet where it is going, but what we know is the oldest trade ship of the world. Now we start the excavation with Institute of Nautical Archaeology, which is based in Texas and A&M University. They are our partners, and we are using high technological methods in this shipwreck, and such as robots, excavation devices, underwater speaking cabins, and etc. Now, this is, in my opinion, the modern shipwreck excavation. Not only the normal shipwrecks, we are also focusing to the Paleolithic. It means that 70,000 years old or 50,000 years old human remains, which were already under the caves of the Mediterranean coastline. So now we already start to cave diving to find the human remains from these Paleolithic periods. What we have, this is our present ship. It has a new high technological, we can say, decompression chamber for 5 person. And this is our new ship. Will be on the sea in this May. It contains good cranes to use sometimes to work for the habitat process and recompression chamber and enough luxury rooms, cabins for the staff, for our master or PhD students, or in future, for example, if we plan to organize a habitat in the Mediterranean coastline of Turkey, we can use this infrastructure in the future. This is what we are doing, and yes, to habitats, at least to have more experienced master and PhD students, we can use this kind of availabilities. And I don't know other colleagues how they are using this kind of systems for underwater archaeology. But now when I'm thinking, I think that we can use them at least for the experience for our students and for our staff. Thank you very much, Martin.
We had some talks about it before, and you were mentioning one mission that you have about 55 meters deep.
Yeah, yeah. One of the excavation. This is the oldest shipwreck. It is between 45 meters to 55 meters.
And at that time, we were talking how it would be if we would have something like, Peter Weiss presented his inflatable habitat. How it would be if we could settle one habitat there and bring some people there. And maybe you should get connected with Ian Koblick another time again, because he also has this underwater archaeology project that he was mentioning before you heard it. And
I was very interested when he's talking on the subject. I am not very aware, but I'm also the General Secretary of ICOMOS Underwater Archaeology Committee, and in present time I know everyone almost in the world. But until now I didn't hear, and it will be wonderful to know more detail. For example, if there is some publishing, it will be great, and it is great honor to meet you, by the way.
Hakan, if I could say a couple of words. For 8 years, we have our foundation, Aurora Trust. Do you remember Aurora Trust? Timmy Gambin from Malta?
Yeah, of course. Just 3 weeks ago, we were online together, actually.
Timmy was our archaeologist, and as of last week, a foundation on which I'm on the board of, it's called OSIF, has received the Ray Dalio ship, the Alusha, and we're bringing it to the Met. And we have all kinds of equipment, and I am part of putting together archaeology programs. So let us continue to talk.
Yeah, it will be very nice, actually. I want to know many details, and I don't want to take time to other people who are already online, but it will be wonderful if we have another conversation next week, for example, or at least by emails.
Yes, let us do that.
I would like to join. Don't miss it.
Of course.
So just one more time because the subject of the meeting is undersea habitats, of course. Do you think there will be a need for, let's say, mobile habitats for, let's say, 4 archaeologists and 2 technicians, let's say 6 people or 5 or 4 people maybe, to have them and to study underwater archaeological sites?
Yeah, I believe that it will be very beneficial, but of course, to say more thing about it, we just need to have some experience, some knowledge, and probably will be very helpful to us on the subject.
We have to keep in mind then that underwater archaeology is, I mean, we would need another sponsor then for them. If we would have a mobile habitat to use in underwater archaeology, we need a third party now who puts, let's say, an advertisement on the habitat or on the mission logo or whatever. So this is something we should keep in mind as well. But when I talked about interdisciplinary purposes, this is what I meant. If we have a mobile habitat, we use it, let's say, for Peter Weiss astronaut training somewhere. Then we bring it to an underwater archaeological site. Then we use it for ocean conservation missions and this kind of things. The more sectors we have, the more possible it will be that we find the financial backup for it, you know. This is the whole thing I wanted to say.
I deeply agree with you, by the way.
In 2015, I designed for Croatia because they have a shipwreck there at about 35 meters. They're working on beautiful job. They wanted to do saturation diving. I designed a habitat that you could actually truck anywhere in Europe on the road because it came in 3 pieces. And the life support van provided a decompression chamber, which during the winter when you have tech diving, could go with the tech diving clubs and be used as a backup support system. And the whole habitat can sit in a parking lot during the winter and be used during the summer months when diving is good. So I have what we did up for that program available if anybody was interested.
Perfect. So
Excellent.
Oh, I think we should all continue to look towards getting a true community living under the sea.
Yeah, we intended to have Andrew Melchior here, who was about to talk about arts, culture, and creativity. He's working with international artists in music for virtual concerts. He's a producer of a record label, and he's very much in technology for this kind of new media. Unfortunately, he's not here, but maybe Brendon Traxler, who's the founder of Atlantis Sea Colony.
Yes.
It's not Undersea, it's sea. It's not colony.
Yeah.
It's colony. We had that before. You are thinking about this since the last 20 years.
Yeah.
What do you think? What kind of a cultural background is there? I mean, like Jules Verne was dreaming of being underwater. I mean, why people want to go to the moon, to Mars, underwater? What do you think about that?
Yeah, I think one thing that can be said from this whole thing is it gives people the opportunity to dream. I think it's one thing that has come apart with the space. You see what Elon Musk and Jeff Bezos have done is people are dreaming again about the future and about what can be done. You see artwork, you see people designing stuff. Everybody's thinking more about that. So I think from a artistic background and just from a psychological background, there's a hope. And I think that's one thing we're trying to do is educate people that there's a hope still here on Earth too, and especially under the water. I think with the community aspect, that has been huge for our project. Like you said, I started with this back in the 90s when I was in high school, dreaming about it at that point in time, and it's just grown from there. So with community, Yahoo groups back in the early 2000s, and now we have Facebook, LinkedIn, Instagram, all these different social media platforms where we can reach a large audience and educate them and encourage them that, hey, we've got a huge ocean out here, and nobody's really doing that much as far as tapping into the business applications of it, scientific applications, and then the personal applications of it.
What do you think? What is the young generation thinking about living underwater or have the possibility to go underwater and stay there for a while or something?
I think once they hear about it, they're excited about it. I think once again, it's one of those things where people don't honestly believe that you can do it. I think it comes back to education. There's a lot of the young people that a lot of times it's instant. If you don't know about it quickly enough, they're going to pass on to the next thing. So it's one of those things where education, and that's why for our project, we're so vocal on social media, because we're always trying to be out there talking about it on all different platforms and keeping people engaged in the idea of underwater habitats, and that, hey, there's a lot of people out here working on these projects. Get behind, if you're not going to get behind us, which is fine, get behind one of them, because there's a lot of ocean out there and there's a lot of different opportunities for it. But yeah, the young people, I think, are jumping on board too. I know our following expands a bunch of different, from, teens to older ages as well. So I think there is an interest out there. It's just reaching those people where they're at.
Right. What I notice every time is that if you tell somebody about underwater habitation, they think like, we go 1,000 meters deep and live there and stuff. So if you tell them, oh, it's more like 9 meters or 20 meters or 50 meters, let's say, then they are a little bit disappointed. But this is actually the place to be for me. I mean, like, I spent really long hours underwater as a diver only, not as living there, and I never want to come back, and I really want to stay there for a longer time, and we'll do that.
Yeah, absolutely.
Just in the break, we had a very little conversation with Jan Koblick one more time, thinking of, hey, what can we do in between the missions, and he was, maybe he can say it himself, he had this one habitat that you could take out of the water, and then I said, what about just closing it down and keeping it underwater and not using it for a month or something like this? What do you think about it? If you could repeat that, that was very helpful, I think.
I just told Martin that when the pandemic started, we closed the Jules Undersea Lodge down, and it was closed for 1 year. And we opened it up about 8 months ago. And all we had done is pump air down there and, keep the air conditioners going. And it was just like the day we left it. We've now refurbished it. It's wide open, and we're having all kinds of programs and media coverage, scientific missions, archaeology missions. It's just like new.
Well, this idea came to my mind when I saw images of Jacques Cousteau's conch shelf garage. He had one garage which looked like the skeleton of a, how you say that, a sea urchin, right? Where he could, where he had a little submarine, he could lift it in and maintenance it. And 40 years after it was closed down, some divers went there again. I mean, every time divers go in, but I saw some picture that on the upper part, over the windows, of course, at the upper part of the habitat, there was still tons of air. It was like there was one person in it, and I think it should be equivalent to three tons of buoyancy inside there, which was very surprising to me. So it came to my mind, okay, if we have a habitat and we don't use it for a month, well, we just close it down, we leave it there, and this is it. So interesting comment anyway.
Can I talk with, address this to Brendon? Brendon, my primary foundation, which is called Marine Resource Development Foundation, runs marine environmental education programs here in Key Largo. We've been doing that for 35 years. And our whole goal is to expand marine education around the world for students. And so I've started a Caribbean teacher initiative where I'm giving scholarships to Caribbean nation teachers to attend our summer workshops. And then they go back to their island nations, and we send them back with a whole program on how to get the kids motivated in mangrove nurseries and seagrass restoration, coral reef restoration. And I'm trying to expand that to other nations and parts of the world through this new foundation called OSEAF, which now has the Ray Dalio ship, the Alusha, and we're taking that around the world. So if you have any input as to getting us involved for a lot of virtual participation from students around the world, where they earn the right to run an ROV from their classroom and be a participant of our program. I'll bring you on board if you have any input with that. I need help.
Well, I'll be down at Jules in May, so.
All right.
So we'll talk. We'll talk.
This is, of course, thank you for this bridging to the next subject, bringing up ocean conservation for the marine environment. There's Sylvia, Earle as well on our guest list, and I mean, I'm following up her since a long time, of course, but what was really striking for me one time, she said in one interview that we have to maintain a human presence on the seafloor. This was every time staying on my mind. And I really would like to hear her opinion about how habitats could be helpful for marine conservation, if she hears me right now.
I can see me. I'm in the lower right-hand corner.
Now I can see you too. Now, you said in one interview once upon a time, we have to maintain a human presence on the seafloor. That was really, I read it 150 times, and I think there was a reason. I'm doing this since 16 years now, and I tell you, I do it for the next 16 years until we have this habitat underwater. So, what do you think? How can underwater habitats serve marine conservation, because this is one of the main reasons why I want to do that anyway?
I think the primary advantage of prolonged time under the sea or anywhere is the gift of time. It's a gift of time. Jane Goodall had 15 years, day and night, and continues with observations of one species in one place in Gombe. And by really getting to know the animals that she was studying, she recognized that everyone was an individual. They all have faces. They have personality. There's a social structure. They communicate among themselves. They show fear. They show pain. They show pleasure. Through that long exposure, Jane has been able to really transform social thinking. Not just scientists, but people generally have been just nudged or given a new way of looking at the rest of life on Earth. We really need to do that. For me, that first experience of staying underwater for 2 weeks, day and night, able to go out and spend 8, 10, even 12 hours during a 24-hour period, getting to know individual fish. There was a moray eel that lived some distance from where our home base was. We got to know that eel. We called him Puff, like Puff the Magic Dragon. But instead of having dragon-like characteristics, we realized that moray eels are actually curious, they're gentle, and unless you're something that they regard as edible, and we weren't on that list, they're just amazing animals. It's spending time with them. I got to know the individual barracuda. Some of them were shy, some of them were more aggressive, and hey, that was only in 2 weeks. Imagine if we have long-term observation stations where we can get to know the creatures on a personal basis, get to see their social structure, get to know how they communicate. And anyway, we can do that with in and out visits. Another hero of mine, Jim Miller, is another one of my heroes, who let women participate as aqua babes back in 1970.
Aqua babes, yes, right.
I mean, it was exciting. That another is Jeannie Clark, who I don't think ever got to saturate underwater, but she used submarines and was a pioneer in the 40s and 50s and on through the end of her long and illustrious life. But notably, she became acquainted with a little fish within diver depth, lived in a burrow in the Red Sea. And over 12 years, she got to know that fish as an individual, observed it, not saturated, but time and time again, went back to see that fish that lived in that place. At the end of her observations on that, as a good scientist, she should have, captured the fish, put it in formalin, and stuck it in a museum somewhere, but she did not do so. Why? Because she had developed what we all have more of a tendency to develop about life in the sea. She had an empathy for that fish. She just, enough already. I had thousands of photographs of this little fish. What more could you learn by sticking its dead body in a jar? We do have to have reference collections, but getting to know life in the ocean on their own terms, not by taking them out of the ocean and examining them in our laboratories, but to use the ocean as our laboratory. I've had a chance to now saturate on 10 different occasions, several times in the Aquarius underwater laboratory, and think about the opportunity there for numerous scientists over years getting to know that place very well because of the gift of time. Getting to know, I remember there's a barrel sponge that lives just outside the entranceway to the laboratory. That big barrel sponge has been poked and prodded and instrumented and documented by dozens of scientists. We've gotten to know that individual barrel sponge pretty well, among other things, realizing through instrumentation and observations that, sponges don't have what we think of as a nervous system. But the individual components of a colonial organism like that sponge communicate, and they do it probably chemically. But how? Or maybe, I don't know, maybe there's another mechanism. But certainly they communicate, because if it's touched anywhere in its structure, all of the elements of that colonial creature respond. In a sense, they kind of shut down because they're responding to something that affects all of them potentially. There's so many things that having the opportunity to not just go in and out, or if you go in and out, to do it repeatedly in the same place. But so many times as a diver, I have just begun to glimpse some critical piece of behavior. A little damselfish guarding its garden, and a big fish comes by, and that little fish, darts up and takes on this much larger fish, punches him in the face with its face. And I'd like to see how it all comes out, but I look at my gauge, I've got to go back to the surface. I can't see it through. But with the gift of time, you can just stay there. You've got hours. And if you have to go back and charge your air, okay, but then you can go right back to look at that damselfish and maybe see the sequence play out. I don't know why it's taken us so long to really gear up and not only using mixed gas and exposing scientists or anyone who wants to go spend long times under the sea. But I look forward to the time when we really get around to having one atmosphere habitats in much deeper than our physiology will allow us to go, breathing a mixture, either of compressed air or a mixture of gases. I mean, compressed air is really convenient. And, it's possible to do this far into your life, but there comes a time when, even though you're in pretty good shape, the idea of saturating has certain medical concerns. At one atmosphere, you can get into a taxi, be taken in a little submersible down to a 1 atmosphere habitat, theoretically, at the deepest parts of the ocean. If you can go up into space, hundreds of miles overhead, why should it be such a big deal going 7 miles under the sea, or any place in between, at 1 atmosphere? Engineering-wise, it's possible, but we have to develop the enthusiasm and get those who have the capacity, either through government support or through the gazillionaires who are out there wanting to have, the next great adventure, whatever the heck it is. Why not get to know this planet from the inside out? Never before has there been greater urgency about getting to understand the ocean. We have better maps of the moon and Mars and Jupiter. We have more investment in going high in the sky than we do in our own part of the universe. I'm happy to be able to be around in the 21st century to see the interest in ocean exploration and ocean care scaling up. Why? Because we have to. Our existence depends on it.
Very good. Thank you very much. That was a very nice message, really. Like you said about this one bar atmosphere, and just came to my mind that Phil Newton just had this vision of vent base alpha, he called it, which is a one bar habitat right next to these black smokers, and to mine the kind of dissolved metals from the smoke there. And when I heard it first, I said, yeah, come on, that's too much, I said. But actually, the longer I think about it, I mean, like, maybe not in the real pitch black dark deep sea, but actually, why not? Why not? Because if you go to the ISS, you cannot open the door and get out of the ISS and say, I just want to feel how the space feels. No, you have to take on your astronaut suit. You have to get out in your astronaut suit, which is a little spaceship, let's say. So if we have a one bar station underwater, we have to find a solution for docking any shuttles to it without that it's...
But it's possible. It's just a matter of...
Yeah, right.
I mean, it's not an engineering impossibility. We got all the ingredients to do it right now. If we had the enthusiasm to direct our attention to doing that.
Right. About ocean conservation, I was investigating kelp forests some weeks ago, and I found out, I'm living here in the Eastern Mediterranean. There are no giant kelp here, but there are some Mediterranean kelp, which are like, as far as I remember, 1 meter or something like this. But of course, they are endangered, like every life underwater. So I was thinking, if we would have some kind of a habitat next to one of these kelp fields, or in the middle of a larger field, I think that would also help to conserve it, right? Isn't it?
Absolutely. The key is knowing. You can't care if you don't know. I mean, you might know and not care, but you cannot care if you don't know. And the existence of kelps, cold water organisms that are so rich with life, as critically important perhaps as coral reefs in terms of the diversity of life.
Right.
Charles Darwin, in his expeditions around the world, found on a single blade of kelp more than 100,000 organisms, representing more than a dozen different categories of animals. I mean, that's diversity writ large. The ocean really is where the action is. And even in the Galapagos Islands, Darwin did not dive, so he missed seeing the kelp that lives right on the equator in cold water, beneath the warm surface water in the Galapagos, where light penetrates sufficiently deep that photosynthesis powers kelp below the thermocline, that near the surface you find corals and you find tropical species of fish like parrotfish and surgeonfish, but underneath the thermocline it's like Antarctica is right there on the equator, and you've got these beautiful kelp forests with cold water species living side by side with warm water species, like the kelp forests you're describing in the Mediterranean.
So there was this Australian Lloyd Godson who made some kind of a small habitat project in a lake and stuff. And what I really liked from his project was he made live connections to schools, universities, everything, so they could talk live over a big screen to the guy living under the water. So again, I was thinking this would be, if you make it, if you advance this idea a little bit, that would be the key to take the young generation into the underwater environment, I think. And especially with this new internet technology, we can have 4K video transmission directly from beneath the water. So I think this would also be a...
Some of this is already being done with like Aquarius.
Right.
During one of my saturations there, we called the White House and I got to speak to Hillary Clinton. And she congratulated all of us living underwater. On another occasion, I was actually outside with a helmet connected to the Aquarius laboratory, connected to a float on the surface that was connected to the internet.
Right.
And I had a chance to appear briefly on the Jon Stewart show for a moment of Zen, as he called it, sharing the view from deep within the Florida Keys to the world, thanks to the technology that did not exist. Jim, back in the days of Tektite, we were not able to do it then, but speaking to the space station.
Right.
That's really a long connecting from the bottom of the ocean to the skies above in ways that, you know, it's really, you're absolutely right, a way to share the view and get people excited about why ocean exploration is really urgently needed. And it's more than just the surface view, taking samples, living underwater, experiencing the ocean. Ask any astronaut, is it okay just to send instruments up in the sky? Or do we have to have people up there sharing their perspective? And, you know, it's a qualitative difference.
Yes.
We need it all. We need all the tools, but the ability to actually have the experience is irreplaceable by a camera or a robot.
For anyone who missed it before, Tektite was a very interesting project in the 70s, I think, with Jim Miller and Sylvia Earle. At that time, as far as I know, just correct me if it's not like that. She was leading an all-female team there, and their name was the Aqua Babes, which is very good.
Oh, we were also called the Aquanauties. That was my
favorite. Right. And I really like your special title, which is Her Deepness, which is absolutely fitting. This is really good. Jan Koblick, I would like to ask if you have to say something additional to this ocean conservation subject as one of the pioneers of underwater living.
Well, first of all, hi Sylvia. We haven't seen each other for years. We do live transmissions almost weekly now from the underwater habitat. We're really using the multimedia aspect of that. We also do virtual programs with students from all around, where our instructor is out in the boat on the water, and we have a classroom that is participating with us as we do marine science, both in the seagrass, the mangroves, and the reef. Right on. We just have to expand that to thousands and thousands more kids.
Right.
One of the critical objectives is not just getting to know the ocean, but to get that dimension of empathy, of caring. Right now, only, less than 3% of the ocean is protected. Places where even the fish and the lobsters and the shrimp and the squid and the octopus are safe. I mean, deliberately safeguarded from extraction. That means 97% of the ocean is open for business. And that is just too much. We are destroying the very underpinnings of what sets Earth apart in a universe that is not really friendly to the likes of us. Caring for the ocean has to be a high priority. 3% is simply not enough. On the land, it's not enough land protected either. Only about 16% of the land. You know, less than 20%. How could you survive if you have a bank account that you keep taking from and never protecting the main source? We've been taking from planet Earth throughout our history. And 21st century human beings are really lucky because we're the first ones to actually see how far we have taken this habit of taking, and how going forward, protecting, call them assets if you will, but protecting our life support system, the living systems that generate oxygen, that capture carbon, that maintain planetary temperature and chemistry in our favor. We still have a chance to reverse the decline and move toward recovery. But what does it take to get there? It takes, first of all, knowledge. We got to know we've got problems, and then to act on those problems to have solutions. And I'm really excited for the kids of today because they know so much more than I did as a kid. I mean, we could not know what Earth looked like from afar. We could not know what it's like to live underwater because nobody had done it when I was a child. Now we know we've got the tools, so we have the capacity, and we certainly have a sense of urgency. We just have to get about it. And I think it's not just the kids, but I think it's, you know, firing the kid in all of us to say, let's go. We can do what no generation could do before, to embrace this planet with the kind of care that will restore health to the systems that keep us alive. And kelp forests, seagrass meadows, mangroves, old growth forests on the land, intact deserts, really have solutions to problems we need to understand. It's protecting nature. And by living underwater, we're able to enhance our perception and our understanding. And okay, the human history that's there underwater. You know, Bob Ballard is fond of saying that the greatest history of humans is not in museums. It's still out there underwater for us to tap into and discover. And importantly, link it to the natural history of the nature of the ocean and where we have come from and where we might ultimately be going.
I could listen to you the whole day, really, seriously. You are absolutely right, yeah. So, I mean, I think that was the best message we could have for this conference. That I wanted to take you to the conversation as well now, Jim, about the future of underwater habitation. I mean, like, this would be the last topic of this meeting. What do you think? I mean, how it should go on? Can underwater habitats serve old marine conservation? Can they help younger generations to get a better feeling for the marine environment? If you would have a comment about that, it would be very interesting for us.
Yeah, I do have a comment. I would say at least every 3 or 4 weeks, I have a young person in person come up to me and say, how do I become a marine biologist? There is a real potential about college kids or young people who just want to dive, of course. But in the marine archaeology, they say, you mean you can find that stuff down on the bottom? You know, and that kind of thing. So I think the audience is there waiting to be trained. And Jan's program down there, it was amazing the first time I was there. The enthusiasm shown by these kids running around with their stocking caps and everything, waiting eagerly for their next assignment at his facility. Excuse my speech, but I have a lung problem.
No, that's perfectly fine.
Oh. Anyway, to answer your question, yes, there is an audience waiting to be trained or at least made aware of the oceans.
Right.
Of course, they're fighting an audience who thinks that codfish come in a can and so on. But I think the audience is there, and I think the kind of programs I've heard today are just what we need.
Right.
And I think if we do them with existing organizations, I don't mean all PhD programs or just college graduates, but I used to get, when I was a little more active, I used to get these letters saying, please send me everything you know about the ocean. And by the way, my report's due the day after tomorrow. And I suppose you all get that kind of mail. So you're polite and say, well, a little more time. Anyway, that would be my answer to your question.
Yeah, thank you very much, and I really appreciate that. Yeah, there are enough people here, as you have seen. There are many people more who were about to join the conference. I'm sure they had their reasons why they were unable to join now. There are people of all kind of with all kind of different expertises. So I just want to encourage anyone who's just thinking of, oh, why not? Let's just at least get some information about underwater habitation, to contact one of us and to get a glimpse of how is it possible. It's not magic, but I think, as Sylvia said before, we have to maintain this human presence on the seafloor. This is my complete belief, and there's not so much time left anymore. And yeah, contact one of us and get your information and help us to make this dream real. This is what I want to say in the end. What I want to do is, if you allow me, that after the conference tomorrow, the day after, I will send you an email, and I will ask you if you think we should continue this conversation sometimes. We don't need dozens of participants at every time, but if you think, yeah, it could be helpful to this subject, then maybe we can meet once in a month, stream it over YouTube, whatever, and keep the conversation alive. That would be very nice. But what I want to avoid, I said in the break as well, is that we make an echo chamber, that we just talk amongst each other and it stays there and nobody cares actually. But it should be somehow that whoever we meet, whoever could be helpful there, should be informed and invited to this conversation then. This is just my proposal. I will ask you by email later, and we'll see where the whole road goes. Huh? In this sense, to all of you, my very big thanks that you didn't refuse my invitation. And especially to our pioneers here, Ian Koblick and Sylvia and Jim Miller. but also to all the others, of course, like Peter Weiss from Spartan Space, and I think we got real good insights here as well, like Hakan Öniz about underwater archaeology, and you see there is a very big variety of activities that underwater habitats could serve. So this is my message. Thank you everyone to that you joined, and I hope to see you again one day.
J'aurais aimé être parmi vous lors de cette rencontre et je remercie la formidable initiative de Martin Hans de Calamar Park. J'espère que notre rêve de vivre sous la mer deviendra bientôt réalité, car c'est de l'océan que naîtra le destin des civilisations à venir.